Silicon Valley spent a decade and $1 trillion building a digital brain. Large language models, reasoning engines, systems that can write code, plan logistics, and pass the bar exam. And somewhere in that decade, the industry forgot a basic law of physics. A brain without muscle cannot turn a wrench. It cannot flip a switch. It cannot lift a cargo box off a warehouse floor. Intelligence without a body is just a very expensive conversation. While American labs were optimizing parameters, one country was quietly building the muscle. Not in a research paper, on a factory floor. By the middle of this year, that country controlled the physical hardware required to replace human labor at scale, and almost nobody outside the industry noticed until the shipment numbers came out. Stay to the end. We're going to show you the exact choke points in the robotic supply chain, why Tesla's commercial humanoid fleet effectively doesn't exist yet, and how global trade rewires itself once labor runs on pennies of electricity instead of dollars per hour. Here is the number that should have been the biggest tech story of the year. In the first half of 2026, Chinese manufacturers shipped more than 97% of every commercial humanoid robot sold on the planet. Not led, not dominated, 97%. Global shipments hit roughly 19,100 units in 6 months, nearly quadruple the volume from the same period a year earlier. Shanghai-based AgiBot alone shipped about 8,400 of those units, a 44% market share, overtaking the previous leader. Hangzhou-based Unitree shipped close to 5,900, another 31%. Between just those two companies, 3/4 of every commercial humanoid robot shipped worldwide this year came straight off Chinese production lines. Now set that against the Western narrative. Tesla's Optimus, the robot that was supposed to define this category, has not sold a single commercial unit to an outside customer. It exists in the low hundreds internally as a demonstration asset walking around a Tesla facility. That is not a rounding error. That is the entire Western commercial fleet, compared to a Chinese industry already shipping tens of thousands of units into real industrial and commercial deployments. This didn't happen overnight, and it isn't magic. China didn't build a humanoid robot industry from zero. It repointed one that already existed, down to the machine level. Take a high-speed surface mount technology line, the equipment that places thousands of microscopic components onto a circuit board every hour, originally built to assemble smartphone motherboards by the hundreds of millions. That same line, with a tooling change measured in days rather than years, now populates the control boards that run a humanoid robot's joints and sensors. Take an industrial die-casting press, the kind that slams molten aluminum into a mold under thousands of tons of pressure to produce an electric vehicle's structural chassis component. That same press, with a new die, now stamps out a robot's structural skeleton, the load-bearing frame that has to be light enough to move quickly and rigid enough to survive a fall. None of this required new capital. The SMT lines, the die-casting presses, the robotic arms that already do quality inspection on the factory floor. All of it was purchased and fully amortized years ago against smartphone volumes and vehicle volumes in the tens of millions of units. The humanoid robot industry didn't have to raise capital to build factories. It walked into factories that already existed, already depreciated, already staffed with engineers who understood high-tolerance mass production, and asked them to build a new shape. That is near-zero tooling friction. It's the single biggest reason China could go from a handful of prototypes to 19,000 shipped units in 2 quarters. The industrial base was never the bottleneck because it had already been paid for by a previous decade of consumer electronics and electric vehicles. And these aren't showroom units. Over 70% of everything shipped this year is already working inside real operating environments, and the tasks tell you exactly why. Inside battery cell manufacturing clean rooms, Humanoid units are handling cells straight out of formation ovens, components running hot enough and sensitive enough to contamination that extended human handling introduces both safety risk and defect risk. A robot doesn't need a break from the heat and doesn't shed skin cells into a clean environment. On EV and electronics assembly lines, units are running repetitive spot weld inspection, passing a sensor head over thousands of weld points a day, a task that is brutally monotonous for a human inspector, and exactly where human attention degrades fastest, which is where defects slip through. And inside, unheated, cavernous fulfillment centers, the kind running through Chinese winters with minimal climate control, humanoid units are sorting heavy, irregular freight, packages that don't fit on a conveyor sorter because they're the wrong shape, the wrong weight, or oddly balanced. This is precisely the job category with the highest human turnover in the entire logistics sector, because it's cold, physically taxing, and thankless. These robots aren't replacing pleasant jobs. They're being deployed first into the jobs nobody wants to keep doing: hot, repetitive, or cold and heavy, which is exactly where the economic case for automation is strongest and the resistance to adoption is weakest. Now, the single hardest engineering problem sitting underneath all of this: joint torque. A robotic arm lifting a real object needs to multiply motor force dramatically before that force reaches the joint. The same reason you'd shift into a much lower gear to pedal a bicycle up a vertical cliff face instead of a flat road. That force multiplication happens inside a component called a harmonic drive, a precision reducer that converts a small, fast motor spin into a slow, powerful, tightly controlled joint movement, with almost no mechanical backlash. In the West, these are built like aerospace hardware. Teeth are cut and finished by hand or on low-volume precision machines. Tolerances are verified individually, and lead times stretch into months because each unit is treated as a bespoke, one-off precision instrument. That approach produces an excellent part and an unscalable supply chain. In China, the same component is treated as a standardized, repeatable consumer part, built on automated high-volume grinding and machining lines that already hit micron-level tolerances every day, because those are the same tolerances required for smartphone camera modules and EV motor windings. The engineering target doesn't change. What changes is the production philosophy. Instead of one machinist perfecting one part, an automated line produces thousands of parts that are already, by design, within tolerance. This shift alone drops the cost of one of the most expensive components in the entire robot by roughly 90%. When your core joint hardware costs a tenth as much, and the factories to build it at volume already exist, mass production of a physical humanoid stops being a research problem and becomes a manufacturing problem. And manufacturing problems are exactly what these industrial clusters have spent 2 decades solving. Tracking a supply chain shift like this one, from raw shipment data down to the specific machine tooling that made it possible, is exactly the kind of institutional-grade analysis this channel exists for. If that's more useful to you than casual tech hype, like the video, drop your take on the hardware race in the comments, and subscribe for more of these breakdowns. Because once you can see a supply chain this clearly, the next question isn't whether the hardware works. It's what happens to the price of human labor once it doesn't have to. Here's where a hardware story becomes an economic one. A human worker in the developed world costs somewhere between $20 and $30 an hour, once you account for wages, benefits, and downtime. A humanoid platform running continuously draws a fraction of that in electrical input, closer to the running cost of a household appliance than a payroll line item. It doesn't need brakes, doesn't unionize, doesn't get sick, and depreciates on a capital expenditure schedule instead of a wage schedule. Once physical output is decoupled from human wages, the entire logic of where you locate manufacturing changes. Factories no longer chase cheap labor markets. They chase cheap electricity, cheap capital, and proximity to whoever controls the hardware supply chain. That is a direct threat to every economy that built its manufacturing base on labor cost arbitrage, including the very regions that, for the last 30 years, absorbed manufacturing work from the West on exactly that basis. Manufacturing sovereignty, going forward, doesn't belong to whoever has the cheapest workers. It belongs to whoever controls the actuators, the reducers, and the production lines that build the machines that replace the workers. Here's the part that keeps this from being a clean story of total Chinese dominance. China controls 97% of the hardware. It does not control the brain. These platforms still depend almost entirely on Western compute to function at all, specifically NVIDIA's Jetson Thor platform, which runs the neural networks responsible for perception, balance, and precise object tracking in real time. Without that chip, the robot is a very well-manufactured statue. On top of that, some of the highest precision components, specifically certain classes of ball screws used in fine motor control, still come out of European supply chains, particularly Germany and Japan, where decades of precision machining expertise haven't been fully replicated elsewhere at the same tolerance. So this isn't a single choke point, it's a dual choke point. China holds the muscle, the West holds a meaningful share of the brain and some of the finest components inside the joints. Whoever eventually controls both ends of that chain, mass-produced bodies, and the compute plus precision parts that make them usable, controls the pace of an entire industry. Right now that control is split, and both sides know exactly what leverage they're holding. Hardware and geopolitics aren't separate stories anymore. They're the same story, told at different resolutions. A 90% cost collapse on a single mechanical component just rewired who builds the physical world's next generation of labor. And the countries that missed it are going to spend the next decade trying to catch up on manufacturing they could have owned. Next video, we're breaking down another hidden physical mechanism quietly reshaping the architecture of the modern world. See you then.